Hello, my name is Henk. In this video I will discuss the design and the implementation, and I also do a demo of the software which I created for this music box hardware. So you can play any MP3 file you want, and I also discuss a couple of details. After this video you should be able to adapt it to your liking, and you can also download these slides which I show and the software from my website. Hi, my name is Henk. This is the second part for the MP3 player, the software. If you like these videos, then please don't forget to subscribe. You can do that by the button in the lower right corner or on the YouTube channel itself. So let's go to the software. We will divide it into several parts. First, the structure of basic functionality. Then I'll discuss a couple of details and then a demo. First of all, after a reset, we need to make sure that the hardware is initialized correctly. That means setting ports in the right direction, that kind of stuff. And then we will go to sleep, because that's what this application is mostly doing, sleeping. And we will wait until we get an interrupt. And that interrupt occurs by the peer sensor. So after the interrupt, we will call a routine which will wake up the system and which will turn the power on. And after that, we will set a counter to the maximum value, and I'll come back to that later. Then we will start to play a song, and we will check if the song is ended, yes or no. If it is not ended, then we will simply wait until the end of that song. If it is ended, then we will start the next song. And that's actually a loop. So that loop will be constantly executed until we reach a certain amount of time, and then we will go into sleep again. And I don't really care about the amount of time, so therefore we use a counter in software, not a counter in hardware, simply something which counts down, and as long as the counter is not 0, we will continue in the loop, and otherwise we will return to sleep mode. And then there is another thing, because what would happen if you make the counter, for instance, 1 minute, roughly. That means that after 1 minute the song stops playing, and that's maybe not a good idea. So we want to make sure that as long as there is a human detected, that we will continue playing. So that means that the interrupt should also trigger that counter to be set to the maximum value again. So each time the peer sensor detects somebody, the counter is set to the maximum value, then we return to the loop which counts down, etc. Something which is Arduino specific, so maybe you know this, and if not, then this might be interesting, because normal systems start with a main function, and Arduino uses a setup and loop in a sketch. So what actually, where does that come from? Well, there is a main.cpp in your system somewhere in the Arduino installation folder. And I printed the most important part of that routine on this slide. So the main is called, and then it does some initialization. Then the setup is called. So that's the setup of the sketch. And then in an infinite loop, the loop function from the sketch is called, and it does something with a serial event run. And that's an endless loop which you see in this for statement. Don't know why Arduino decided to do this by themselves instead of giving the main to the end user. I would have expected that, but okay, it is what it is. But there's no magic in software, so you can always find out how this works by searching. Then we have a playlist, and what if you want to make that playlist random? Well, assume you have 10 songs or 10 MP3 files, numbered from 1 to 10, and you put them in a playlist, and now you want to have that list random. So instead of 1, 2, 3, 4, 5, a random order. Well, you could pick a number and put it in that playlist, and then pick another random number, put it in the playlist, but it should not be the same as the first one. So you can imagine that picking the last one is very obvious what the number would be, and using that random function is and checking will be a time-consuming task. So that's not a good idea. So you can ask Chat GTP. The reply was use the Fisher-Yates shuffle method. And that's actually an interesting algorithm, which is shown on this slide. So you fill first the array with the numbers 1 to 10, and then you count down from 9, the last index used in that array, down to 0, and you swap that position with a random selected position. Yeah, this algorithm will always execute in the same amount of time, while the other one wouldn't. What we also need to do is taking care of the interface protocol. So that's over the UART, serial interface. And the commands are in a command string, which starts with a start byte, and that's always 7E. Then you get a version, which is always FF. Then you get a length, which is the number of bytes of the command without start and end byte. So in this case, when we omit the checksum, then that is always a 6. Then you get a command byte, so that's actually telling the chip what to do, playing a song or whatever. Feedback could be set to yes or no by applying a 0 or a 1, and that feedback is actually more or less an acknowledge if the command is correctly received. Then you have data, MSB, most significant byte and the least significant byte, optional a checksum, and an end byte, which is always EF. The reply is always 10 bytes, so that always includes the checksum. There is, by the way, a library for this device, and I used that library for the list of commands, but it was not completely correct, or it also did not include the checksum check, which I added. Another thing, how do you test this stuff? Well, you can use songs, for instance, but they have a duration of a couple of minutes, and you don't want to wait for a couple of minutes. So what I did was looking on the internet for a spoken clock, and I found one, and there you have all the numbers in a small file. So the file 1.mp3 actually is someone only saying 1. Songs or files should be put or can be put in directories, and that directory should be 2 numbers. The files should always start with 3 numbers, and then you have some free text and then a .mp3. I did not really find a good specification for this. You see a screenshot about a part of the specification which I cannot read. I tried it with 2 numbers, and there it simply doesn't work. So it must be 3 numbers. Okay, we've seen now the intention, what the setup should be in the software, or what we intend to do with the software. Let's now have a look at the software itself. So first of all, I started off with a couple of comments, and that's what I always do. Describe the system in short, on what CPU is it based, which other modules I used, which libraries I used, and if there is documentation, then I also put it in there. Then we get a couple of defines. So these are defines for the pins which we are using and for several modes which we are using. And then we instantiate the serial interface for the MP3 player and connect the pins to that interface. Over here you have a list of the commands for the MP3 player, which I took over from the library, and I added comments where it was not commented. Then this is the size of the playlist, and we have a couple of global variables which we will use. So this is actually the playlist. The function setup is called first, so let's go to that item, and then you will see that what we shown in that bubble in the diagram before, that we will do initialization of the pins. We turn the power on, we wait for half a second, we set the timeout to the maximum value. The MP3 player is not yet initialized, we didn't do that. And then what I always do is put all the debug statements for the serial print, so not to the MP3 player but to the console, in a if statement, and with this boolean you can turn the debugging on and off. And then we have meaningful feedback on the console to test if our application is working as intended. We put some numbers in the playlist just to be sure. There is no interrupt received yet, and last but not least, we attach the interrupt pin to the function wake up. So as soon as we have a rising edge of this signal, the function wake up is called. And that's actually the last statement in the setup, and it should be the last statement because we for sure don't want to have an interrupt during the setup. Then, as shown in the main CPP, we enter that infinite for loop, which calls loop each and every time, and that's the loop function in the sketch. And over here we immediately go to sleep. And what does that function go to sleep actually do? Well, it sends a message that we are now entering sleep. Then it checks if the MP3 player is initialized, yes or no, if the interface is initialized. In this case, that's not yet done. If it is done, then it sends a couple of commands and puts it in sleep mode, for instance. That was testing what the power consumption would be in sleep mode. This statement over here is extremely relevant because it will turn the pin transmit, which is per default high, to a low state before we go into sleep. If we keep it high, then that will lead to draining the battery because it will lift up the VCC of the MP3 player, and that's not a good idea because it will consume power. Then we turn the power off, we send a message that we are going to sleep, we wait for a second, we enable the sleep mode, we set the sleep mode to have the least amount of power, and then we put the CPU into sleep. So now our system is sleeping, and the only way to make it awake again is by that interrupt, and that interrupt will call the function wake up. It will check if we have seen this interrupt already, and that's not the case. So now we immediately set that flag to true, meaning we are awake. We set the timeout to the maximum value. That was the timeout which keeps our playing songs in a loop until that counter is counted down to 0. We send a message that we are awake. We disable the sleep mode, so this is more or less defensive programming. Then we generate that random list by the algorithm earlier shown. We exit now this wake up routine, so that means we return to where we went into sleep mode. That's over here. So we continue with a message that we are now just after this go to sleep statement. We turn the power on, we make sure that the amplifier is also not in shutdown mode, and we wait for some time, and then we initialize the MP3 player because the power is just turned on, so it had a hard reset. The boolean is also set to true, that it's now initialized, and we set a couple of commands to reset that module and to make sure that it knows where it has its storage, so that's the SD disk, and we set the volume to the maximum. And then if there is data available from that interface, that could be because we went into sleep suddenly in a previous time, then we read that data and dump it. So this is more or less to make sure that there's nothing in that buffer. Then we specify some things before we start the loop, which counts down if our timer is 0, yes or no, and playing songs. So we are using folder number 4. The song index in the playlist is 0. We have a maximum of 10 songs, 0 to 9. And the song ended is a boolean, and that's currently not true. There is no song playing, so song ended is true. Then if we enter this loop, if a song is ended and this was true, then we will start a new song. So the data for that statement is the folder should be in the most significant byte and the song should be in the least significant byte. So that's what we do over here. And we do that by the playlist song index. So the playlist 0, the number which is in there, that's our song. Then we increment the index for the playlist. And if it is the maximum, then we return to 0. So this loops over our playlist. And actually over here, we send the command to the MP3 module and it will start playing. And song ended is now false. And we, of course, do a nice message where we are in our code. Then we get to what we saw in the bubble diagram, that we will wait for this song to be continued. So we start reading from the MP3 player, and it sends a couple of commands or feedback, but actually we are not interested in it. We are only interested when the code is 3D. That means the module indicates that the song is ended. So we make that boolean true, song ended is true. We decrement the timeout and we print that value as a decimal value, and then it starts all over again by playing the next song and checking if that song is ended, playing the next song, checking if the song is ended, as long as the timer is larger than 0. So we also discussed that this timeout should somehow be set to the maximum value again to keep playing this song. And that's done by the per interrupt. So if we go again to that interrupt module, which was that interrupt function which was called wake up, then we are now in this else statement if we get an interrupt because we are awake, and this sets the timeout to the maximum value, and we make a nice notice over the serial interface to the console to know where we are in debug mode. And that's actually the basic functionality of this software, which you can extend to your liking. There are a couple of details. So, for instance, I did not discuss what that send command actually does. You can see it over here. It implements the data structure which should be sent to that module. So starting with a start byte, etc., what I showed in the slides. And then in debug mode, I'll print what command it actually is. That's convenient. And over here, the command is actually sent by this write statement where the buffer data is sent. And we put it on a console also. This is, by the way, a statement from the library. There was also a reply, and that's done over here. So where we are waiting for data, we do a decode MP3 answer. So what is that decode MP3 answer? Well, first of all, it will get a reply from the module and put it in reply data. So that's the 10 bytes of data which we get from the module. And if it was 3D, what we earlier mentioned, to check if the song is ended, then indeed 3D means that it completed a song, and in the data the number of that song is shown. That's a different number than the number on disk, by the way, so be careful about that. And over here you see a couple of other replies which you could get and what it actually means. But this get reply, how does that work? Well, that's somewhere at the bottom, and over here we read our 10 bytes of data from the MP3 player, and we do a couple of checks. For instance, the first byte should be the start byte, the last byte should be the end byte. Then over the data, the checksum is calculated, and that's a 2's complement, so you invert that data after putting this filter on top of it, and you add 1, then you split it into the MSB and LSB, and that should be what you got from the interface, from the module. If that's not correct, then we print an error, otherwise we return the data, and if the start and stop byte was not correct, we also print an error. So that's the software. Let's do a small demo of this application. So first of all, we will make sure that we download this software into our Arduino. So that's done by pressing this button over here. It compiles it and it sends it to the board. I'm not going into the details in this video about how to set it up. So that's done now. So we could go to the serial monitor, and to show the process, let's make this a little bit larger. If we press the reset button of that board, then it will show that we started the software and we are entering sleep, and we enter that sleep module function. That's, yeah, and that prints that we are now sleeping, so nothing is happening. So if we would trigger that peer sensor, then it will start playing the songs in a random order from the songs 1 to 10, actually saying 1 to 10. Let's do that. Okay, I turned off the power. So what we see over here is that we are waking up, and we create a random playlist for the first 10 numbers in that array, so we don't care about the rest. Then we are just after that sleep function, and we will send a couple of commands to play to start playing songs. So that was the reset, and to make sure that we have the SD card, setting the volume, etc. And it started off with playing number 9. So in directory 4, song number 9, that's actually what you also see in the data over here. Then our counter is counting down from 60 down to 0 before it would stop. And over here we are reading the data, so we will check if there is if the song has ended, and if the song is ended, then we will start playing the next song, and in this case that is number 6, and then we play song number 3, song number 5, etc. So that should correlate with the numbers which you heard just a couple of minutes ago. And in the meantime, we are still counting down. So this is the whole process. We press the reset button, and then we are to sleep again after a reset. And if we trigger the sensor, then it will start playing those numbers. And if we now trigger it again, and we will stop this, so I'll pull the plug, then we will see that that counter should be reset to the maximum value again by just triggering that peer sensor. So we start off with 59, 58, 57, 52, and over here we see that we increased the timeout, so that was the interrupt routine, and then it's back to 59 again. So that also works very nicely. You can download this from my site if you want. There's a link in the first comment where you can do that. Also the slides can be downloaded over there. We've come to the end of this video. If you like this video, then please subscribe to my channel, and thanks for watching. Goodbye.